Here is worksheet 2. Okay, got it right? Worksheet 2. Tamjid,
Yes, sir.
you can see the screen, right?
Yes.
Worksheet 2 is there. So which one you have problem?
Worksheet 2.
Worksheet 2,
Extended
I mean
theory
you
part.
have uh, theory you have problem. That means notes you have problem or worksheet.
Worksheet, the
Okay,
theory part.
yeah, that means structured part.
Hmm.
Better to say structured part, huh?
Hmm.
That means this one, right? So where is your problem?
Sir, my problem is in question number 4, the last question.
Okay, question number 4. You have problem. Question number 4. Okay, this one, right?
Hmm.
So you send me the worksheet? This one.
Uh, I think so.
You send me, right? So this part is not
Hmm.
done yet, or you did but you are confused.
I think so I did, but I'm confused.
Okay, so how can you read the question and what you are thinking? Let me understand that one first. From there, I will start.
An astronaut standing on the moon throws a stone vertically upwards. The stone leaves his hand at time t equals to 0. The line on figure 4.1 shows how the velocity v of the stone varies with time until time goes to 2 seconds.
Hmm.
Hmm.
Until 2 seconds. It is
Hmm.
shown until 2 seconds, right?
Hmm.
Then
A. After rising, the stone falls. The astronaut catches the stone at t equals to 6. There is no air resistance on the moon.
okay. Then continue.
So complete figure 4.1 until time t equals to 6.
Okay. Now you have to complete the figure. That means you have to complete the graph. The graph is
Hmm.
given till 2 seconds. You have to complete it till 6 seconds.
Hmm.
So, what do you think? Uh, what will be the shape of the graph?
Uh, I think so. There will be no curves because there is no acceleration since there is no air resistance. I expect it to be
Can
like
you please say loudly? There will be no curved line.
uh, yes,
Why?
because
Why
there
there
is
will
no
be no curved
acceleration.
line?
Because there is no acceleration, and no acceleration means no air resistance.
Yes, that is the point. You are saying no acceleration. That means there is no acceleration of free fall in on the moon. This is wrong. There is acceleration. The acceleration will work constantly as there is no
Oh,
air resistance. It will work as free fall acceleration. Okay.
okay, okay.
Yeah.
Okay.
So if it is constant acceleration, then our velocity time graph gives always a straight line.
Hmm.
And the stone is thrown upwards, vertically upwards. That's why the stone will be decelerated first,
Hmm.
right? And after deceleration, then it will return. Uh, that means it will come back. It will reach to the highest point or maximum height. Then it will stop. As it is thrown upwards, it will work against the gravity, right?
Hmm.
So the velocity will decrease, uh, and it will be the rate, the velocity per time, uh, decrease in velocity per unit time, that is deceleration. There will be deceleration. That's why we are getting this curve, right? That is negative
Hmm.
gradient. And
Hmm.
after you know 2 seconds, we if we continue this straight line, then we will see that the curve, the graph is crossing 3 seconds.
Hmm.
The graph is crossing 3 seconds. Then from here we understand that in 3 seconds it reaches to zero velocity, right? Here the velocity
Yes.
value
Maximum.
is zero. So it means that it reached maximum height where the object is stopped, right?
Hmm. Hmm.
And after that we will again get the object return to the uh, we can say the surface of the moon, right? It will return back to the surface of the moon, and it will continue. This line will continue this way here. After 3 seconds, uh,
Hmm.
you know one thing, and that is the time it requires to reach maximum height from the throwing point. It will return back. It will
Hmm.
return back in the same time, within the same time, in the same place. Okay, so it
Hmm.
will take another 3 seconds to reach the place from where the stone was thrown, and also it will have the same velocity. The velocity you got here, 4 point, uh, I guess it is 4.8, right?
Yes.
So here also in negative part, the velocity will be 4.8. And if you continue this line, then you will see that it
Hmm.
will reach to 4.8. Okay, with a ruler, your ruler should be, you know, a big ruler, right? 30
Hmm.
centimeter ruler, and that one, if you you place the ruler here and uh, align to this line, then it will reach here. Okay, 4.8. Okay,
Hmm.
now one thing you can ask that here we have negative uh,
Hmm.
negative velocity we are showing here. So when returning back, hmm, the one we
Hmm.
are throwing, as we are taking this one as positive, the one returning back, it is opposite to the starting one. That's why we are taking here negative values, because it's related to velocity. So velocity has a specific direction, right?
Hmm.
And if one direction is opposite to another one, then we are using opposite symbol or opposite sign.
Hmm.
Now it's clear.
Yes. Yes.
And second part, they are asking you state the value of t when the stone is at its highest point. Already I told you this. Can you tell me?
Yes. T is 3.
3 seconds. Say the time
3 seconds. 3 seconds.
with unit. Then,
Sir, I have one question.
sure.
Uh, Sir, at first I thought the graph will be like a V shaped, like
Yeah,
the
yeah.
V.
It is happening for students. Uh, as I said you, it's not a speed time graph. If it is a speed time graph, then you could take that one. Okay. It is velocity time graph. So the sign will be opposite.
Yes, yes, yes. Okay, okay.
Okay. It will be other side of the graph.
Hmm.
Now calculate the acceleration of the stone between 0 to 2 second, right? So
Hmm.
here you have the initial velocity, final velocity.
Yes.
Initial velocity is 4.8, right? Then final velocity you check here how much it is. It seems 1.6, right?
Hmm.
So if you for put it in the formula, that v minus u by t, time is already given 2 seconds. Then you'll get the acceleration.
Yes. So I got it. 1.6 meter per second square.
Yeah, on moon the acceleration value is 1.6. Then anything else more?
Yes, the C part.
Okay, C part. Can you read it and think?
Uh, at, a stone is thrown vertically upwards on the earth with the same initial velocity. State two ways in which velocity time graph for this stone differs from figure 4.1.
Okay, so
I think the line will be more steeper. I mean, we'll have a higher gradient, negative gradient, higher negative gradient.
our stone is thrown vertically also on the earth. So yeah, it will be with more gradient, right? Then any other point?
And second one will be it will have a different what different t value.
To reach maximum height.
Yeah, it will reach at a different maximum height.
Yeah, then if it is going, for example, if it is going through this part, right? Then there will
Hmm.
be less time, right? It will reach
Hmm.
faster to the maximum height. Okay,
Hmm.
okay, these two points. So correct. So now what you have to do, you please complete it, huh? Complete this
Hmm.
worksheet and resend it, huh? Then I will check.
With the cover, right? With the finished
Yes,
cover.
yes, please give the
Okay.
cover so that I can have the name and date. That's very important. Okay. So this worksheet is over, right?
Yes.
Now we will have the discussion on notes, right? You have
Yes.
seen the notes, right, on dynamics.
Hmm.
So you have any? Should I go through the whole notes, or you already went there and you have some confusions? Then we can go faster.
Yes, sir.
Which one you prefer?
Yes,
Should
sir.
I go to the whole notes, or you will just mention your problem? That one I will discuss.
Yes, yes. I will just mention my problems and
Then
uh,
we can go
you'll
faster,
just
right?
explain them. Hmm.
Okay.
Sir, can you give me 2 minutes? I will just write the answers.
Sure, sure. I'm giving you 2.5. Okay.
Okay.
Do it. No problem. Don't worry.
Where is the thing? Yeah. Sir, sir, hello, sir.
Yes, tell me.
Sir, I'm not able to get the cover photo. I mean, the,
Okay, you are not able to cover photo, so I will send you it. Okay, I will send you it, and tonight you send me. Okay, by tonight, no problem.
okay.
I'll send you, no problem. So it's your notes on kinematics, right? Kinematics already we discussed. Already.
Hmm.
Oh, this one should be dynamics. The heading is wrong, right? The heading should be dynamics. There is some mistake in the. Only that one should be corrected, right? The
Hmm.
other things are fine. It is topic 3, uh, dynamics. So where is your confusion? Can you please tell me, share with me?
Yes, my first problem was in types of forces, gravitational force, second and third bullet point.
Which one? This one. Types of forces, gravitational force, right?
Yes, second and third point.
Okay, second and third one. That is a long range force which acts at a distance. That means gravitational force uh, is like with it has a long range, right? It can work for a long distance, like moon and earth. They are far away from each other, but still they have gravitational force to each other, right?
Yes.
Sun, planets, satellites, all are far away from each other, but they do have gravitational forces to each other. So it's a long range force. Okay. Second point is clear.
Yes.
And now third point is like can usually be neglected unless one of these masses is very large. Like uh, in comparison to uh, Earth and our size, our mass, that is very small, right?
Hmm.
And in comparison to us, the Earth's mass is very large. That's
Hmm.
why uh, Earth has Earth has some gravitational force, which one we can understand or we can realize easily, right? But
Hmm.
if we think that we two persons are sitting side by side, you and your friend is sitting side by side, you also have gravitational force to each other, but you don't understand it, don't realize it,
Hmm.
right? So that time we
Hmm.
are neglecting that one. Got it? That
Oh.
is negligible. We are considering it as negligible.
Hmm.
Clear? This is the third point. Now it's clear.
Okay. Yes.
Then
Uh, yes, I'm checking.
yes.
Hmm. Uh, yes, sir. Frictional force. Last 2 points.
Okay, which page?
Page number 3. Frictional force. Last 2 points.
Oh, frictional force. Last 2 points. I'm going there. Page two, page three. Okay, here.
Hmm.
It's related to contact force. Uh, so
Hmm.
here contact force now consists of normal contact force and frictional force.
Hmm.
Contact force is the resultant of N and F. For this one, uh, we have to go to here.
Hmm.
Here we have normal force. Hmm. So do you
Hmm.
understand what is called normal force? Normal force is also called contact force. Okay,
Oh
same.
yes. Then yes. Yes.
So clear to you now.
Hmm. It's just the addition of those
Hmm.
addition of frictional force and normal contact force.
Hmm.
So, sir, it's like so. What's the difference between contact force and normal contact force?
Same thing, same thing. That is, you have directly working downwards. That one is normal. Okay, perpendicular. Normal means perpendicular.
Hmm.
So here we have normal contact force N and frictional force F.
Hmm.
Okay, contact force is the resultant of N and F. That means you have here two forces N and F, right?
Hmm.
So their resultant will be contact force.
Hmm.
Okay.
Okay. Okay. Hmm. Uh, yes, sir. Next one also. Viscous force, drag force.
Viscous force or drag force. Where you don't understand?
I don't understand the whole thing.
Okay, viscous force and drag force works in fluid. Fluid means both gas and liquid. Okay, so when I gave you one example about playing football, when you are uh,
Hmm.
running and playing football, that time if your speed is more, then you are getting more air resistance.
Hmm.
The air resistance you are getting, that is viscous force or drag force. Okay.
Hmm.
Similarly, in water, if any vehicle is going through the water or any liquid, that time
Hmm.
if the speed of the object is more, then it experiences more viscous force or drag force.
Hmm. Yes.
So that's why they are saying when a solid moves in a fluid, it will experience a resistance to its motion. That means against the motion, it will face a resistance that is called drag force or viscous force. Okay, dependent on the
Hmm.
speed of the object. That means if its speed is more, then the viscous force will be more. Okay, for
Hmm.
objects moving at low speeds, viscous force is proportional to its speed. For objects at a high speed, the viscous force is proportional to the square of the speed of the car. It can be anything, like not only car, it can be anything. Then depends on the fluid involved. Some of the fluid they have more density, so there will be more viscous force. Okay, like if you are dropping one steel ball in water, you will face some. The steel ball will face some viscous force, but if you are dropping it in honey, more denser one,
Hmm.
then it will face more viscous force, right?
Hmm.
Because it has more denser. So here they say higher
Oh.
higher higher viscosity in denser fluids, dependent on
Hmm.
the nature of the fluid. Again, same thing.
Okay.
Okay.
Yes. This tension is easy. It's easy. It's just
Mhm.
opposite to weight.
Mhm.
Uh,
Actually,
and
all this I gave extra. These things only if I write the name of the force, that's enough. We do not need too much explanation. These things we do not require now. Nuclear force, weak force. But I gave so that my student gets some broader ideas, right?
we need to have that.
Uh, that's why I gave it. Viscous force you do not need even O levels, right? They will discuss in
Hmm.
A levels. Okay, then.
Sir, I today I memorized till this much, but I did not go further.
Okay. You did not get time. You are busy, right?
Yes, I was busy in English and chemistry.
Okay. So, should I discuss all this, or you will
Hmm.
manage some time at home to go through them?
Sir, you give me 5 minutes. I can
Okay, have a
tell
look.
you
Okay,
where am
have a
I.
look. Okay, I'm giving you 5 minutes, no problem. After 5 minutes, we will start the class again. So, for
Hmm.
the time being, I'm taking a break for 5 to 6 minutes. Then
Hmm.
we are praying. I am praying. Huh? I'm praying,
Hmm.
offering the Salatul Asr. Then we will
Hmm.
start. Okay, no problem.
Okay, sir.